All right. Good evening and welcome to this lecture series on working with surface modeling. And then today we will be talking at we'll be looking at the possibility to flatten flatten I mean, let's say a curved surface that we have been able to thicken. This can be very useful when you want to test the ability of your model to be able to be used to be used in a sheet metal production processes. This is just an example, so there's nothing so detailed about it. So let's just say we're designing a simple protective face mask. There wasn't any thing except that we just did a curve. So yeah, we assume that the curve, every face mask should be able to have a curve to protect you from the dangers of industrial production or something like that. So first of all, I have a curved surface here that I've done. I can explain that a little bit. Because this lecture series is a bit very brief one. So first of all, how did I do the curved surface? I've been able to sketch two construction lines here in the x and y directions, and then I just did a line here and then dimension the line to 200 mm, and then I have so I'm going to revolve it around, and from the origo it's going to be 116 diameter. So you can see the 8 there, that's the radius. So let's come out of the sketch and then enter the curve and enter the, in case you didn't know how that went, let us see here whether we can clean up the surface so you can see how the revolve was done. So let's just more or less start everything from the beginning. So that was the sketch we just we did precisely now, and then we're saying insert surface revolve, and then that's going to be the revolve there. That's just going to form the surface, and that's going to form the, that's going to be the, well, that it's wrong here. So this is going to form the center line for the revolve, and the software quickly picked up the surface, and it's going to be mid-plane because blind will give us a bit of we wrongly dimension the revolve. So uh, I could have just explained that, but it's a brief lecture, so a brief tutorials. I mean, so when we revolve it, the thing is that I decided to do the mid plane because I want the front plane and the right plane to be at the appropriate place. Since I wasn't using a 360-degree revolve, I was just using a 240 degrees revolve. If I had used, if I have used like, let's go back to that revolve because it's important to get some clarification, understand how these softwares can be very interesting. If I have, this is a mid plane, but if I have used the blind, which actually could have worked better if I was revolving at 360 degrees, but let's say if I have used the blind for a 240 revolve, you can now compare the position of the front plane. If you look at through there, you can see that the front plane is not actually at symmetry with the revolve, and then I could also be a problem with the right plane. So the best thing with this revolve was to also choose mid plane, so the revolve is going to be right, so that we can set our parameters at the appropriate dimensions. So that is it. Okay, let's move ahead and make some cuts. Let's see here. We want to use the front plane to make a cut on the screen of this protective screen. So let's just do a simple drawing here. Let's start by getting a center line. Honestly, I prefer using center lines a lot so I can get my dimensions to work properly if I was to make a change in my dimensions, or I was to change make changes to my modeling. So that's pretty good. Yeah, that's okay. Okay, and then we can use the center triangle, and then I see here center triangle could work. Yeah. Okay, yeah, let's center triangle is not necessary. Let's try a normal triangle, because just that's what we want to get here. We just want to get the chords, two chords, and then we could place a symmetry between these lines. Yes, and then so from the screen we could just choose dimension. We say 70 mm. Oh, that's okay. That's wrong. 70. It's now. What happened? Let's see. No. Okay. It's been a let's no. Okay. Okay. Typical 2D tree. Yeah. 2D sketch. Let's come up. Uh, what dimensions were we using? Okay. Let's see here. Oh no, that's pretty big. So 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 that's me. Yeah. Let's say that's 80. So that's pretty good. So we just want something like this. Let's drop our symmetry line a little bit. Um, some of the dimensions may not be necessary. I'm just trying to give to be able to get an example shown. 15. Okay, and then let's dimension that line, but we'll change it to construction line later. Let's say that's going to be 50. So let's change it to construction line. We'll just put a small arc. So 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 we're going to use this for a cut. Let's make it tangent. Yeah, and let's get a tangent tool on this side. That's pretty cool. Another tangent there. So I think we can make this cut. If we're not so happy with the dimensions, we can but I think it's pretty cool. It's just an example, so it doesn't really matter. So we can, this is now going to be the we're going to use this to make a cut through this profile. Yeah, so sheet metal trim. So use this as a tool, spray there, and then let's standard cut. This ones we are going to remove. This surface we're going to remove is this. Oh sorry, oh sorry, we got two surfaces in there. So so I hope you choose the right one. Yes. Okay. So and then let's just do another crazy cut downstairs, down there on this side. There's another crazy cut here, so it looks like something serious. So yeah, so we'll do a crazy cut here. So we can just use a center triangle and make a cut by the side. This is just basically to illustrate the central goal here is to be able to flatten this pattern, and then we can so make that coincident, make these three parts equal, but it's not really necessary. So so and then we make a bit of dimensions, and then let's say we dimension this part. So that's a 50. So okay, let's test. Okay, let's add some radius to the cut. So if it says so it's going to be an error somehow, but because we have already said that the path, that's okay, make it a bit higher, 10. So we're just going to get a rounded path there. Then so if we make a cut, we can add radius in this sections later. So if we approve this, there's going to be, of course, an error there. Just say this okay. So let's see whether, let's get this corrected by removing the equal to, because that's just what is causing the error now. Alright, so let's get out of the sketch. Let's use to make a cut in that direction. So that's called a trim in Surface. Trim in Surface works like cut in solid modeling. So trim is still going to be a standard trim. The trim tool is this, and the path to remove is going to be this and this, and let's approve it. Okay, so we got this shape. Let's try adding an offset radius at the edges. See, I think that should be able to work. Offset radius at the edges. Let's see. So let's see here. Alternatively, we can thicken it a bit, so it's gonna be, we're gonna be snapping into it. So let's say feature based thicken, and let's say we're adding in the outside direction. Let's say we're thicken with 2 mm in the outside direction. So that's okay. And then let's add up the radius, the fillets, to fillets in this. Let's fillet this edge. We snap into the edge. So we'll fillet this edge. We'll fillet this edge. We'll fillet this. We can actually set the fillet to select automatically, but that's not the point of the lecture today, the tutorials today. So we can just do it manually, so that it takes everyone time to get hands on to what we are doing. So otherwise you can actually do some selections, which was the basis which came out first. So let's just fillet manually. So it's gonna be pretty time consuming, but it's okay. So okay, so I approved. Let's, so all right, so let's see screen. Yeah, all right, so we're going to flatten up this curved surface that we have taken. So we now go to insert. The interesting thing here is that you go back, even if now we have a solid modeling, as you can see there on the, yeah, on this on our program mode here. So you can see it's a solid body, but here to get to flatten this, we have to use flatten from the surface menu. Okay, so we want to test to flatten this. This is the body we are going to flatten. Then we have to choose the exact fixed position for the flat. I think that we should try, we can actually try this radius. most of these vertex can work. But let's see. Okay, that's really doesn't work. But now if we take it, so it goes. Yes, it goes. It meshes. It meshes the whole solid into different. It produces a mesh of the solid, and is able to flatten the solid. So if we say approved, so we can see the flat part of the solid. This also enables us to calculate if uh, our to test at every point in time if our surface modeling, in case we are working with sheet metal, will be able to be flattened in the sheet metal. Thank you so much. Stanley Wong again with my technologies and engineering. Bye bye.